Now let us write the code for generating all the Armstrong numbers between this lower bound and upper bound. Now we know how to check whether a number is an Armstrong number or not. We have already derived this code. Okay, now I am going to modify this code. So what this piece of code does is it checks whether number a is an Armstrong number or not. Now if I substitute a with a 1, this piece of code checks whether 1 is an Armstrong number or not. If I substitute a with a 153, this code checks whether 153 is an Armstrong number or not. So as a varies from lower bound to upper bound, this piece of code checks all the numbers between lower bound and upper bound for Armstrong numbers. Okay, so how can you make variable a vary between lower bound and upper bound? You know how to write the loop. It is for a in range lower bound comma upper bound. But you know, if I write ub here, the range working of range is like this. This returns all the integers starting with the LB and ending with the UB minus 1. So if you want UB, it must be written as UB plus 1. Now the range function returns all the integers starting with LB and ending with the UB plus 1 minus 1, which is UB. Now these are statements associated with the for loop. They should be indented properly. So just select the statements, press the tab key. So now it is indented properly and these are statements corresponding to for loop. So now what about the working of this piece of code? For a in range LB comma UB plus 1. Suppose your lower bound is 1, your upper bound is 10. So range 1 comma 11 means it returns all the integers from 1 to 11 minus 1, 1 to 10. So a gets the first integer in the range, that is 1. This piece of code checks whether 1 is an Armstrong number or not. If 1 is an Armstrong number, here Armstrong displayed. Okay, now a gets the next integer in the range, that is 2. This piece of code checks whether 2 is an Armstrong number or not, so on. So here as a varies from lower bound to upper bound, here you get all the Armstrong numbers. Now instead of displaying Armstrong, I want the number to be displayed. So just type a and let the ending character be space. Okay, and if it is not an Armstrong number, you don't have to do anything. So just remove this. Okay. So now this piece of code will generate all the Armstrong numbers between lower bound and upper bound. You can save the file, run the program by pressing F5. First, you should start with option number 1. You should read the bounds. Okay, so option number 1, read the lower bound 1, read the upper bound 100. Now you can use option number 2. What is that? Generate all the Armstrong numbers. So these are the Armstrong numbers between 1 and 100. So this menu should appear in a new line. Let me modify that piece of code. Okay, so if you want this menu to appear in a new line, what you can do is at the beginning you can type one print statement. Okay, so this will insert a new line so that this menu appears in a new line. Now save the file, Control S, run the program F5. The lower bound is 150, the upper bound is 1000. Now you can see all the Armstrong numbers between 150 and 1000. They are 153, 370, 371 and 407. So you get all the Armstrong numbers. Okay, so kindly make a note of this one. How did you get this piece of code? First we wrote the code for checking whether A is an Armstrong number or not. Okay, then you modify your A varies from lower bound to upper bound. then you will get all the Armstrong numbers between lower bound and upper bound. Now option number 3 is made use of to find the sum of Armstrong numbers between lower bound and upper bound. My next video tutor explains this.